So today what we're going to do is we're going to come up with the derivative rules for all 6 trig functions. And we need to review a little bit trig identities from last spring during distance learning. And this is the sum and difference identity for sine. So if you have sine of an angle plus or minus another angle, so alpha and beta are 2 angles you're adding, or you could be subtracting. And then it's sine of the first angle, cosine of the second angle, and then plus or minus sine of the second angle, cosine of the first angle. And then we also have this for cosine, okay? And then we need to remember the Pythagorean identity, sine squared theta plus cosine squared theta is always going to equal 1. And then we also need to recall these two limits, okay? So the limit as x approaches 0 of sine x over x is equal to 1, and the limit as x approaches 0 of 1 minus cosine x over x is equal to 0, all right? Okay, so we're going to need to use this one and the sine addition one, okay, for the trig identity, because this is what we're going to do. Okay, so if we want to find the derivative of sine x, we got to go back to the definition of a derivative. So this becomes the limit as h approaches 0. I started to write x. Okay, as h approaches 0 of sine of x plus h minus sine of x all over h. So then the next thing we need to do, okay, and this is where we're going to need to use this identity. So in this case, all right, my x is my alpha and my h is my beta, and I'm adding, so I'm going to be adding over here. So this becomes the limit as h approaches 0 of sine of x cosine of h plus, because we're adding, we're going to add here, okay, and then sine of x, or sine of h cosine of x. And all that's doing is replacing this with this one, okay? And then minus sine x all over h. All right, so now what I'm going to do is I'm going to break this up a little bit. Okay, I'm going to rearrange this. I'm going to put this sine x and this sine x together. So this becomes the limit as h approaches 0 of sine of x cosine of h minus sine of x, and then plus the sine of h cosine of x all over h. And then what I'm going to do next, okay, is I'm going to break this up. Okay, so I'm going to break this up into, I'm going to use this addition right here, and I'm going to break this into 2 fractions with a common denominator of h. So this becomes the limit as h approaches 0 of, and it's going to become sine of x cosine of h minus sine of x over h. And then plus, and this one's going to become sine of h cosine of x over h. And then what I'm going to do next is these two have a factor of sine x in common. So I'm going to pull it out. So this becomes the limit as h approaches 0 of, and I'm going to pull it all the way out, and it's going to become sine of x times, and then this becomes cosine of h minus 1 over h. That would be the same, okay, as this. And then this one, I want the sine h and h to be together, so I'm going to bring the cosine x out in front. So this one becomes, or I'm going to sine h over h. Never mind. I'm going to do it like this. Sine h over h times cosine of x. All right. Now, what I'm going to do, okay, so this is the limit of a sum, okay, but I have to do the limit of each of these individually. Now, if you look here, one thing that's wrong, okay, if you look at this one right here, okay, this one is almost the same as this one, right? What's different? The numerator is opposite, right? So what I'm going to need to do here is I'm going to factor out a negative, okay? And that's going to make this cosine of h be negative, and this is going to make a +1, and then I'm going to rearrange it and have a negative out here in front of the sine x, okay? So this is going to become the limit as h approaches 0 of negative sine of x times, okay, so this is going to become 1 minus cosine h, like I said, over h, and then plus sine of h over h times cosine of x. So just rewriting things a little bit differently. Okay, and so I'm going to take the limit of this sum, and then I have to take the limit of each one of these individually. Okay, so this winds up being the limit as h approaches 0 of negative sine of x. And actually, I put the parentheses in the wrong spot. I just caught it. And not that that's wrong, okay? But I actually wanted to have it out here. And then times the limit as h approaches 0 of 1 minus cosine of h over h. And then plus the limit as h approaches 0 of sine of h over h. This is just using properties of limits. And then times the limit as h approaches 0 of cosine of x. Okay, so this limit, well, there's no place to put the 0 for h, right? So what happens as the limit as h approaches 0? Nothing, because there's no h to get for it to get closer to 0. So this just becomes negative sine x okay, the limit as h approaches 0 of 1 minus cosine of h over h. Well, that's this one, but it's just instead of x's, it's h's. So this winds up being, this limit winds up being 0. And then plus the limit as h approaches 0 of sine h over h. So once again, it's like this one, but instead of x's, it's h's, but it's still the same limit. So it's going to come out to be 1. And then the limit as h approaches 0 of cosine x, well, that would just, there's no h, right? So there's no h to get closer to 0. So this is just going to be cosine of x. Okay, so this winds up being 0, and then this winds up being cosine x. So our derivative of sine x is cosine x. All right? So, okay, what's wonderful about this is we never have to do this again, right? This was always true. So the derivative of sine x is absolutely always cosine x. So we never have to go through this limit process. So this saves time, okay? So d dx of sine of x will always equal cosine x. Okay, so that's one we have to commit to memory. All right, now you could go through a very, very, very similar argument and show what the derivative of cosine x is. Okay, and if you did that, this is what, if you did similar argument to this, you would have to use this one, the sum angle identity for cosine. Okay, but if you did d dx of cosine x, that's equivalent to negative sine of x, okay? And we need to know these. I'm gonna write all 6 when we finish all this, okay? And we're gonna use these two to do our next derivative, which is gonna be tan of x, okay? So we need to know the derivative of sine x is cosine x, and the derivative of cosine x is negative sine of x, okay? All right, so let's go to our next page. So what's the derivative of tan x? Okay, so the derivative of tan x, what we have to do to figure this one out is we need to rewrite this. Okay, so a trig identity, the same as tan x, is sine x over cosine x. Okay, so now this becomes a quotient. And now I don't have to do a limit process. I could actually use the quotient rule because I know the derivative of sine x, and I also now know the derivative of cosine x, okay? So here we go. The derivative of sine x is cosine x times the denominator, which is cosine of x, and then minus sine x, the top function, times the derivative of cosine x, which happens to be negative sine of x, all over the denominator, which is cosine x, squared. Okay, so this becomes cosine squared x. When we're going to subtract a sine x times a negative sine x, so that's going to become plus sine squared x. And cosine of x squared is cosine x times cosine x, which is cosine squared x. And then we have a trig identity we need to recall, okay? Cosine squared x plus sine squared x is equal to 1. So this replaces, this right here can be replaced with the number 1. So this becomes 1 over cosine squared x. All right, so what does that mean? Okay, well, 1 over cosine x, let me do it in red. 1 over cosine of x is equivalent to secant of x. So really, this could be rewritten as 1 over cosine x times 1 over cosine x, which would be secant x times secant x, or secant squared x. And so the derivative of tan x comes out to be secant squared x. All right, let's figure out what the derivative of secant x is. And that's next. So the derivative of secant x, we are going to need to rewrite this. And from trig identities, we know that we can rewrite secant x as 1 over cosine of x. And because now that's a quotient, I can apply the quotient rule, okay? So the derivative of 1 is 0 times the denominator, which is cosine of x, minus the top, which is 1, times the derivative of the bottom, which is negative sine x, all over cosine squared x, or cosine x squared, okay? So 0 times cosine x, that's going to just be cosine x. I'm sorry, it's going to be 0. Sorry. That's going to be 0. And then this is going to be sine x. So we have sine x over cosine squared x. Now, there's another way we want to write this, okay? And we could rewrite this as 1 over cosine x times sine of x over cosine x, because that would be sine x over cosine squared x. Now, why we want to do this is this becomes secant x. So this is equal to secant x, and sine x over cosine x, that's a trig identity, that's tan x. So the derivative of secant x is secant x times tan x. So now we've done 3 of the 6 trig functions, okay? So actually 4, because we talked about the derivative of cosine x too. So now I'm going to give you all 6, okay? And that's what we're going to do next. So we know that the derivative of sine x is cosine of x. We know the derivative of tan x. I'm having a tough time talking. Sorry, guys. So the derivative of tan x is secant squared x, okay? And the derivative of secant x is secant x tan x. And the derivative of cosine x is negative sine x. Okay, so we've done all 4 of those. I've told you those already, okay? So what's the derivative of cotangent x? Well, we could go along a similar argument that we did with tan x, okay? But what this would come out to be is negative cosecant squared x. And then cosecant x, the derivative of that becomes negative cosecant x cotangent x, and we could follow a similar argument that we did with secant x, okay? And that's what you would get. All right, so we need to commit these to memories, all right? And so we're also going to have derivative rules for the exponential functions for e to the x and also a to the x. And then we have two more derivative rules, the two logarithms, natural log and log base 10, or log of any base. And then we have the inverse trig functions, and that's it for derivatives, okay? We'll have them all. All right, so let's do some examples now that we know all 6 trig functions. So y equals x minus 10x, and we want to find dy over dx, right? The derivative. So dy over dx is equal to, so the derivative of x, now we got to use the sum and difference rules. Okay, so the derivative of x, it would be 1 minus the derivative of tan x, which is secant squared x. Okay, now, I wish I had you guys in the spring, okay? We can rewrite this, okay? Because we know that cosine squared x plus sine squared x, you need to know this, okay? This is a big one. Cosine squared x plus sine squared x is equal to 1. If I divide each of these by cosine squared x, I'll get a variation of this. So if I divide this one by cosine squared x, I'm going to get 1. Plus, if I divide this one by cosine squared x, I'm going to get tan squared x. And this is equal to, and if I divide this one by cosine squared x, that would give me secant squared x. Okay, now, if I move this around, I would get 1 minus secant squared x is equal to, and I'd have to move the tan squared x over to the other side, and that would become negative tan squared x. So that means this 1 minus secant squared x, and I expect you to do this, it becomes negative tan squared x, okay? So dy over dx is equal to negative tan squared of x, okay? And you want, as best as you can, if you didn't do all the assignments last spring, it's going to come back to you, okay, right now, because we're going to have to do all these trig identities that you were supposed to have learned, all right? Okay, let's go to example 2. So for example 2, we have y is equal to x secant x, and I want to find the derivative of that. So this is a product, so I'm going to have to apply the product rule. So dy over dx is equal to, so the derivative of x would be 1 times secant x plus, and then x, and then the derivative of secant x, which is secant x tan x. Okay, so then the derivative becomes secant x plus x secant x tangent of x. And then one thing we can do here, and a lot of times we're going to want these to be products, okay, for future lessons, okay? And we can factor out a secant x. So this becomes secant x times 1 plus x tan x. And that these would be equivalent, okay? All right, guys, so that's the example number 2. Let's do one more example. For this next example, we have y is equal to 1 minus cosine x over sine x, and it's a quotient, so we should be thinking, quotient rule, all right? So dy over dx is equal to, okay, so the derivative of the top, so the derivative of 1 would be 0 minus the derivative of cosine x, which is negative sine x, and we're subtracting it, so this becomes plus sine x times the bottom minus the top, so 1 minus cosine x, times the derivative of the bottom, which is cosine x, all over the bottom squared, so sine squared x. Okay, so now let's start cleaning this up. Okay, so this would just really be sine x times sine x. So that means dy over dx is equal to sine squared x. This is going to become cosine x, but I'm going to subtract it, so minus cosine x. And negative cosine x times a negative cosine x becomes positive cosine squared x over sine squared x. And then we can do some rearranging. So then dy over dx could equal sine squared x plus cosine squared x minus cosine x over sine squared x. And so sine squared x plus cosine squared x, we need to recognize that. So sine squared x. See, if you don't have these trig identities memorized, you're not going to recognize them, and then you won't be able to do what you need to, okay? So this becomes 1. So dy over dx is equal to 1 minus cosine of x over sine squared x. So that's one version of the answer, okay? So there is some other things we can do because we have this trig identity, sine squared x plus cosine squared x is equal to 1. So I am going to solve this for sine squared x, and so sine squared x is equivalent to 1 minus cosine squared x, which means I could replace this sine squared x with 1 minus cosine squared x. So these are going to be other, and you need to be aware of this because like in a multiple choice test, you may have any one of these as your answer, okay? So dy over dx could also equal, all right, 1 minus cosine x over 1 minus cosine squared x. And then what can happen here is this can be replaced with, this is a difference of 2 squares. And hold on a second because I'm running out of ink. So we switched out the sine squared x with 1 minus cosine squared x. And then this could become 1 minus cosine x over 1 minus cosine x times 1 plus cosine x. And so here my 1 minus cosine x's would cancel, and I'd be left with 1 over 1 plus cosine x. So all of these are equivalent answers, okay? All right, so I need to say this, okay? So this part right here is just other possibilities that you need to be aware of, okay? So other possible answers. All right, and that is it for trig functions, okay? So we're gonna start applying these with product rule and quotient rule, and then we have another rule called the chain rule that we're gonna be learning next unit, okay? So a lot of stuff here, all right? So you need to learn and memorize the 6 trig functions right now, okay? Get them down right now. Get them in your memory as soon as possible, okay? And I will give you a test on all of the derivatives, and just you have them memorized. If there's a way, I'm going to try to do like virtual flashcards. I usually make flashcards for my students. If there's a way, I'm going to try to do virtual flashcards. Okay. All right, you guys, have a great day.